Welcome, everyone, to today's Explainer. So glad you're joining us because we are unpacking a truly massive technological shift today. We're looking at the transition from today's basic communication networks to tomorrow's fully integrated, automated service economy. Really, we're talking about how 6G technology is going to completely revolutionize the way we adopt and consume XaaS, or everything as a service. Forget the days of your network just being a simple delivery driver for your data. In the 6G era, that network literally becomes your intelligent butler.
To really wrap our heads around the scale of what we're talking about, we have to look at the numbers. According to a Fortune Business Insights report, the global everything-as-a-service market is projected to skyrocket to $2.4 trillion by 2029. Trillion, with a T, up from just $437 billion in 2021. So this isn't just some minor passing tech trend, right? It's an absolute economic explosion, and it's being driven by e-commerce, cloud computing, and this constant need for ubiquitous, high-bandwidth access. And as we're going to see today, 6G is the exact catalyst needed to unlock this massive potential.
Okay, let's dive right into this. Just to make sure we're all on the same page, what exactly do we mean by XaaS? Well, remember the days before the cloud. If a company wanted to run a digital business, they had to buy these giant, expensive physical servers, purchase rigid software licenses, and build out massive on-site infrastructure just to keep things secure. It was incredibly costly. XaaS is the increasing servitization of all that tech. So computing, infrastructure, software, it's all simply provided over web networks. You don't buy the hardware anymore, you just subscribe and pay for exactly what you need, right when you need it.
But here's the critical roadblock we're hitting right now. As the demand for these complex services just keeps growing, our current networks are frankly struggling to keep up. When you compare 5G to the upcoming 6G architecture, the difference is literally night and day. You see, 5G was built for communication, full stop. So adding advanced capabilities like artificial intelligence or edge computing requires this kind of clunky add-on or patch approach. It drives up costs and is really inefficient. 6G, on the other hand, is designed from the absolute ground up for native convergence, meaning communication, computing, and AI aren't just bolted on as an afterthought. They are baked directly into the DNA of the network itself.
Think about how a traditional 5G setup actually works in practice, and you'll spot the bottleneck instantly. You have all these extra layers: mobile edge computing, AI, security, all just sitting on top of the core network. Research from China Mobile actually points out that because 5G uses a single, fixed protocol, trying to inject new business demands means you're just stacking new network deployments on top of old ones. It creates a really messy patch system. And for a business, that means high power consumption, crazy deployment costs, and super long development cycles just to get a single new feature out the door. The core of the problem was perfectly summed up by China Mobile's chief scientist of 6G. They said, simply overlays of new capability leads to low resource and cost efficiency, poor business adaptability. And that adaptability part is absolutely crucial. When businesses want to deploy dynamic, real-time services, like, say, managing a massive fleet of automated delivery drones, they need agility. A rigid network that requires custom duct tape patches for every new AI requirement is the exact opposite of agile. It's the ultimate bottleneck, stopping the true everything-as-a-service economy from taking off.
Which brings us to the solution. 6G requires a complete paradigm shift. We're talking about evolving from a standard mobile network into what's being called a mobile information network. It is no longer just about faster download speeds so you can stream movies quicker. 6G is built to be the foundation for every single step of information services: collection, storage, transmission, processing, and application. It's an all-in-one architecture that's completely on-demand, plug-and-play, and inherently open to its customers.
At the very foundation of this new paradigm is the computing and networking infrastructure pool. Instead of having physical hardware dedicated to one specific task, 6G creates this seamless, flexible reservoir of resources. Because of this, the network can dynamically match service provision based on whatever the user needs at that exact millisecond. So whether it's powering the Internet of Things, vehicle-to-everything communication, or extended reality, the network fluidly grabs the right mix of computing power and connectivity on the fly. To make this kind of dynamic pooling possible, the 6G architecture is essentially growing a new, highly complex brain. On top of the traditional communication layer, 6G natively introduces 4 brand new planes. First, the data plane manages all the data storage, collection, and processing while it's in transit. The computing plane handles the raw processing power. The intelligence plane provides a full-life operating environment for AI. And finally, the security plane ensures endogenous, built-in security across the entire board. When you put them together, these 4 planes turn the network into a massive, intelligent, distributed computer.
Let's zero in on that intelligence plane for a second, because this is where that butler metaphor really comes to life. It gives rise to AI as a service, or AIaaS. Because AI is natively baked right into 6G, the network itself is going to host AI models directly within its infrastructure. This means third-party businesses don't need to build their own massive million-dollar AI server stacks. They can just tap into the network's distributed intelligence. The telecom infrastructure literally becomes this agentic butler, translating a business's needs into actions and orchestrating the computing power behind the scenes to make it happen.
And the mechanics behind how this works are surprisingly elegant. 3GPP, which is the group that develops these telecom protocols, is explicitly studying how the 6G core will act as a high-performance broker for these services. So imagine an autonomous AI agent running on your smartphone. When it suddenly needs heavier processing power, it searches for help. The 6G core instantly steps in as a highly secure broker, effortlessly connecting your device's agent to a specialized AI agent sitting on a distant edge server, all using standardized APIs. It's completely seamless agent-to-agent communication, handled entirely by the network. Let's ground this with some real-world applications. When we look at actual projected use cases, the impact here is immense. Take a smart factory, for example. Instead of buying millions of dollars in visual recognition hardware, that factory simply subscribes to the network's AI service for automated security inspections and image recognition. Or think about a smart hospital. They can utilize 6G's AIaaS for real-time, low-latency patient health monitoring, again, as a subscribed service rather than a massively expensive owned system. The barrier to entry for advanced technology just plummets entirely.
But here's a wild thought. AI doesn't just serve the customers, it actually serves the network itself. Because that AIaaS layer is natively embedded, it's going to run the 6G network autonomously. We're talking about continuous machine learning handling network configuration, function management, and predictive analytics. The industry calls this zero-touch operations. It's essentially network as a service with zero human intervention required on the operational layer. The network literally heals, optimizes, and configures itself in real time.
And this incredible level of autonomous management extends way beyond just digital data. It bleeds right into our physical world through infrastructure as a service. Look at a smart city, for example, as outlined by Ericsson. By using 6G's real-time edge computing and secure local processing, municipalities can manage complex physical systems like power grid stabilization and anomaly detection as a simple, managed service. Providers can host AI models right in the network itself, simplifying the rollout and ensuring top-tier security, which means cities can adopt smart infrastructure so much faster and cheaper.
So when you zoom out, you realize 6G is effectively transforming into this all-encompassing XaaS platform. It provides the absolute foundation, infrastructure as a service, by combining communication and computing. On top of that, it offers platform as a service for basic component and data services. Above that, software as a service, specifically those AI applications we just discussed. And it even enables extended reality as a service. Imagine using edge computing to offload heavy graphical processing from your VR headset directly into the network. Your headset gets lighter, cheaper, and more powerful, all because of the network. So, why does all of this matter so deeply? Well, as noted in recent academic analysis, 6G turns to a XaaS platform, laying a solid foundation for business model innovation and reflecting the benefits of intelligent inclusion. Intelligent inclusion, that is the massive takeaway here. By packaging complex AI, vast computing power, and massive connectivity into simple, standardized subscriptions, 6G completely levels the playing field. Small and medium-sized businesses, who make up the backbone of our economy but historically lack the technical resources to build these systems, can suddenly innovate on par with the massive tech giants.
Now, a quick reality check on the timeline here. We aren't going to wake up to this tomorrow. The International Telecommunication Union is actually defining the 6G framework right now as we speak, with standards expected to be firmly locked in around 2026. This means the actual commercial rollout, when this massive, unified, artificially intelligent network fabric becomes a normal part of our daily lives, is projected to land around 2030. So we are quite literally looking at the architecture of the very near future.
Which leaves us with a whole lot to think about. We've seen how 6G shifts the network from a dumb data pipe into this brilliant, dynamic, everything-as-a-service platform. It flawlessly merges computing, data, and communication into one seamless ecosystem. So, I want to leave you with this thought. In a few short years, when 6G makes artificial intelligence and massive computing power completely ubiquitous, literally as easily accessible as turning on your water faucet, what will you demand as a service? Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll catch you in the next one.